Hello, and welcome to the first installation of Janky Bedroom Math. I call this Janky Bedroom Math because this whole setup is so jank. I am using my desktop webcam just turned around. I'm using my desktop headset. I've just propped a whiteboard against the wall on my bed. It's it's not the ideal setup, but hey, it works, right? Anyway, I had to go through all of the pain of setting this up. This is the third time I'm recording this because the first time it didn't record audio. The second time it stopped recording, but this time it's recording. I see it recording audio. Okay? I'm going to talk about this. Nothing's gonna stop me. Nothing's going to stop me this time. Okay? So you've probably already seen this before. You've probably seen this, especially if you're active on Twitter. This has made the rounds so many times. You might have even seen this on Facebook, maybe, or a news outlet that's covered this. You've also probably seen that people are getting two different answers, right? People are getting that 8 divided by 2, right? So that's 4 times 2 plus 2 is 4 equals 16. Or they're getting that 8 divided by 2 times 4, which is 8 divided by 8 is 1. So which one's correct? That's what we're talking about. Which one is correct? The answer is both. Alright? This is a case of an ambiguous expression of multiplication and division. It's like, it's just a bad expression is the thing. The problem isn't that some people are stupid. The problem is that this is just the problem's broken from the get-go, right? So you might be thinking, but the order of operations that we learned in like 4th grade, right? Maybe even earlier. I don't remember when I learned it. That was a long time ago. I'm an old man now. The order of operations that we learned, that implies that we do, maybe you learned PEMDAS, right? That implies that we do multiplication first. Or maybe you learned PEDMAS, and you say, no, we do division first. But the thing is, the way we learn order of operations in school is a little bit broken, because the reality is that we have a 1, 2, 3, not like a 1, 2, 3, 4, 5, 6 order of operations. It's a 1, 2, and 3. First, we look at exponents and roots. Note the and. Then we multiply and divide. Then we add and subtract. Okay? We don't assign one or the other higher priority. They are the same priority. And also there's the overarching rule that we examine parentheses first, right? So speaking of that rule, there is no reason for this to be 2 plus 2. We can just call this. Actually doesn't even need to be a parenthesis there. We can just call this times 4, right? 8 divided by 2 times 4. That's the problem. So this is just an ambiguous problem. Both 1 and 16 are correct. So this is such an awkward position to write on a whiteboard from. It's ridiculous. Anyway, someone I follow on Twitter made a thread about this, and in this thread, a person named Mr. Meerkats says, this is the equation, right? And it should only lead you in one direction. People who are getting 1, people who are getting people who are getting people who are getting 1 are taking the approach that this part over here is separated off in parentheses. And he makes the argument that this is a different expression. But I want to point out that we can take the same logic and apply it over here. That if we separate off 8 divided by 2 in parentheses, that must mean that it's a different expression, right? The reality is that it's not a different expression, it's just a different interpretation of an ambiguous expression. So I want to really reiterate that this is an ambiguous expression. No one's stupid for thinking it's 16. No one's stupid for thinking it's 1. And Mr. Meerkatz, in another tweet on this thread, makes an interesting point. He says, I took 3 math classes in quantitative reasoning just to watch people fumble over math learned in elementary school. Quantitative reasoning, calculators, and elementary school understands that it's 16, and people still swear otherwise. Like, nah, the calculator's just wrong this time. So it's interesting you bring up the calculator and elementary school. Calculators are programmed with a specific order of operations, more specific than our order of operations are. If a calculator were programmed to give multiplication and division the same priority, that would get it, the calculator would get to this point, and it would say, I'm getting 2 different answers if I give them the same priority, and I can't get one answer giving them both the same priority. And so that's a problem when you're making a calculator, because you want it to always give an answer. You don't want it to throw errors on something like this. That would be just ridiculous. So programmers who create calculators, they program in, I think usually it's PEMDAS, not PEDMAS. At least in my experience, I've usually seen multiplication done first. But that's just an effect of programming, not math. Calculators can't interpret expressions the way that we can. It can simply follow a specific route down the numbers to get one answer. And it's also interesting that you bring up elementary schoolers, because like I said, I learned PEMDAS, other people learned PEDMAS. So we get to this point, and that's where our what we're taught fragments. Now, if an elementary schooler was taught correctly that multiplication and division have the same priority, they might get to this point and just say, all right, I'll work left to right, which would be a correct way to do it. Dr. Hannah Fry provided, I believe it was Daily Mail, some images that are hopefully right here of 2 ways to use fractions to reduce the ambiguity, to eliminate the ambiguity, actually, because once you introduce the fractions in the way that she shows, there is no more debate on what to do first, because it's defined in the expression. There's a few things we can learn from this, though. Like Dr. Hannah Fry pointed out, fractions reduce ambiguity, sometimes even completely eliminating it. So, one moral of the story is to just use fractions, because it's not hard to use fractions. Like, this was designed to make people argue about numbers. But if it weren't designed to make people argue about numbers, it would be a bad expression, a badly written expression. So just use fractions, okay? The second moral of the story is that when we look at expressions and stuff, actually, let's even more broad than math, right? When we look at certain problems in the world, a lot of people insist that there's one interpretation that leads to one answer. But it's not always that simple, right? In this case, there's two interpretations. In other cases, there might be three or four, and none of them are inherently incorrect. None of them are inherently correct, but you will always see people insist that their view is correct and insist that anyone with other views are stupid, whatever. This stupid expression ended up, I, I guess, teaching us more the number. Yeah, I'll stick with that. Whatever. I'm done. I don't want to talk about this anymore. This is stupid.